Yo, this is LeetCode 242, valid anagram. Given two strings s and t, return true if s is an anagram of s, return false otherwise. And an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once, right? So if we have three a's in s, we need to have three a's in t, right? If we have one G in S, we need to have one G in T. If we have one M in S, we need to have one M in T, right? Here's an example where we would return false, right? We have a T in string S, but we don't have a T in string T, right? So we would return false, okay? Pretty straightforward. So now obviously, in order for, basically in order for T to be an anagram of S, basically all the characters that are in S need to be in T, right? So what does that mean? That means that that S and T need to be the same length, okay? They need to be the same length. Now, technically we could do something really cheeky, right? Like this, or we could just like we can basically sort S and T and compare if they're equal or not, right? And basically, if we sort them and if they're equal, it'll return true, otherwise it'll return false. Now, the problem with this solution is I'm not exactly sure what interview would let you get away with that. I don't think any interviewer would probably accept that. Now, if you're doing LeetCode just for fun, then by all means, if that's the solution you like, you can go with that. But in an interview setting, I don't think that would be acceptable. So we're gonna use a different approach. Remember that that S and T need to be the same length, so we'll just handle that case first, right? So if the length of S is not equal to the length of T, then we can return false, right? Otherwise, what we're going to do is, the way we're going to approach this problem is we're going to make a hash map and basically count the letters in S, right? A occurs 3 times, right? G occurs once, etc. We're going to make a hash map and keep count of the letters and their frequencies. And then we're going to do that by iterating through S, right? And kind of populating the hash map. And then we're going to iterate through T. And we're going to use the same hash map, right? We're going to go, okay, does N exist in the hash map? Yes, it does, right? We added it right here. Because when we iterated through S, we already added it to the hash map. So does N exist in the hash map? Yes. So we're going to decrement the frequency, right? The value by 1. So right now it's at 1. So now it's gonna be 0. Okay. What about A? Yep. It's 3, right? So we're gonna decrement it by 1. We're gonna have a value of 2 for A. G, we already have a 1, so we're gonna decrement it. We're gonna have 0. Basically, we're just gonna do that, and essentially we're gonna return false in cases where we encounter a letter or character that's not already in our hash map, right? Like, for example, if we go here, if we do it for this example 2, as soon as we do that check, is C in the hash map? No, it's not, because C is not anywhere in S, right? So we don't have a C in our hash map. So we return false because we know that T is not an anagram of S. Likewise, let's say we have another R, right? A second R right after this first R in T. Remember, after the first R, we decremented the hash map value by 1. So as soon as we run into a second R, right, if we were to place a second R right there, we would basically look at our value. Is our value greater than 0 at this point? Or is it equal to 0 at this point? Yes, it is. So we'd return false, right? Because if we're decrementing it once more, it'd be -1. What does that tell us? That tells us that there are more characters, or the frequency of a specific character in T occurs more in T than it does in S, right? So we already have a problem, because we know that if we have 2 R's in T and 1 in S, well, they're not anagrams at that point, right? Okay, so that's how we're going to approach that problem. I know it's kind of a long-winded explanation, but I really want to just go through that using a bunch of examples just to make sure you understand kind of how our solution is crafted. So we're going to do for char in S. If char not in hash map letter, we need to make hash map letter, right? That's what we're going to call our hash map. We're just going to call it hash map letter. So if char not in hash map letter. Okay, what is this line doing? Basically, when we're on a specific character, we're going to say, is that character a key in our hash map? Well, we're saying if that character is not a key in our hash map, then we're going to add that character into our hash map, okay? Right? If we encounter a character for the first time, we're going to add that to our hash map, and the value for that specific character is going to be set to 1, obviously, because that's the first time we've encountered that character. I'm going to say hash map letter for char is equal to 1. Okay? Pretty simple. Else, when we hit this else statement, that means that that character that we just encountered is already in our hash map, so we're just going to basically increase the frequency counter by 1. Also, I have an error here. It's hash map letter, not hash map letters. Hash map letter char plus equal 1. We're just incrementing by 1, right? Every time we encounter a character that's already in our hash map. Okay, pretty simple. Now let's do the thing where we have to kind of iterate through T. So we already have our hash map populated from S. Okay, so we're going to say char not in hash map letter, right? If we encounter a character when iterating through T that's not in already in our hash map, then that means that we're encountering a letter in T that is not in S. So at that point, we're already having troubles because that would not be an anagram, right? Okay. Or the other case is hash map letter. Oh, it is hash map letters. Excuse me. Up here, I called it hash map letters, not hash map letter. It's gonna run into an error if I didn't fix that. Okay, so anyways, so if we encounter a character in C that's not an S, we already have a problem. Or if we have a case where a specific character we encounter is already the count's already at 0, that's also a problem, right? Because that means we're running into a character in T more times than we're running into, or the frequency of a character in T is occurring more than it does in S, right? Like if we have rat here, right? And actually that example of this example is kind of perfect, right? So we have one R here, one R here. If we encountered another R, then obviously we would have a problem, right? 2 R's in T, 1 in S. That's not an anagram at all. Because again, it's not just the letters that we care about, it's the frequency of the letters, right? We need to have, if we have 2 R's in T, we need to have 2 R's in S. Otherwise, they're not anagrams, okay? So in this case, we return false, right? Because those are cases where we don't, those are cases that we don't want, right? Those are cases where they would not be anagrams, right? Else, right? Else, this is where we do the decrementing of the frequency, right? So we do hash map letters, char, minus equal 1, okay? Now, assuming we don't run into any problems, right? We don't return false or anything, then we're just going to return true at the end, because that means they are anagrams, okay? Okay, and it works. Yeah, I kind of had a lot of long-winded explanations, but I just want to make sure you're kind of following along with what our solution is actually doing. So I hope this helped, and I'll see you in the next one.